what does India have to do to move towards 100% renewable energy? As I pointed out, India would leverage solar and wind to the maximum, but look for a third and fourth source of renewable energy. Is hydro possible? Is ocean energy possible? Is nuclear energy possible? Now, all this we did not consider it earlier. We will get up to 70%, for the remaining 20-30% we have to look at these things. They may look bad today, but that is where R&D comes in and they will start looking good tomorrow. All kind of storage options need to be. So far we have looked at primarily lithium ion and chilled water. Of course, tomorrow solid state lithium ion, but they will also be short term storage. Flow battery we will look at, will there be long term storage? For example, zinc air, zinc metal, aluminum air is being talked about. Can they be long term storage? Needs to be seriously examined. Remember, if the long term storage is even slightly more expensive, it does not matter, it will average out. I am not going to store everything, probably 10-20% of the energy. So, that will go up, but may not be that bad. Probably 10% of the energy, 10% of energy itself in the country, if I can do long term storage, I probably will be able to work it out quite well. And 10% of energy, even if instead of 7 rupees, if it is 15 rupees, it adds average of rupee 50. Maybe I can afford that. That is what we have to do. We have to again look at hydrogen, pumped water storage, compressed air. Hydrogen also, the problem is, can I really store so much hydrogen? But all this needs to be really looked at. The third important thing that so far we have not used, if you want to become 100% renewable energy, we have to stop wasting electricity, wasting energy. Many things in India continue to use inefficient, our usage is very inefficient. For example, our air conditioning is highly inefficient. Can I make it more efficient? Then of course, energy efficiency will play a major role, and that is already happening. All our motors used are old induction motor, very inefficient. Can I use more efficient motors? Electric, can I move to, the other thing is I can't continue with petrol, I have to move to electric vehicles. That work has to start today, and first part of our course shows that it is certainly possible. Cooking, we have just pushed LPG all over the country, good step, great thing, moved away from coal biomass, which was worse. We have not moved fully, but because, and the LPG prices are going up, even with subsidy now the poor people cannot afford. Question is, can we move to cooking with electricity, induction stuff? Today even upper middle class uses LPG gas cylinder, already cost is going up, it will start competing with electricity. Sometime you do a computation, and if I can make my electricity there, it will make a huge industry. I have low temperature furnace, high temperature. Low temperature I can use heat pumps. What are heat pumps? Very similar to cold pumps which you use for refrigeration. Whole lot of efficient heat pumps can be developed. Then for a high temperature, that is where hydrogen usage is very good. Hydrogen storage we do not know, but for high temperature hydrogen, make from renewable energy hydrogen and then use it. And we will talk about each of these things in the next chapter. Look at this. In India's largest 38% consumed by industry, 23% by residential, out of which my guess will be about 15% will be urban high income group usage. Commercial is 8%, we can certainly convert. Even agriculture etc., we can look at least their vehicles can move to electricity. And then of course, this is also industry. So, there is 37 plus 5.6, and then there is public water and other things. World, if you see, again industries are dominant. Transport we have to move, transport is not there in this, probably absorbed somewhere, and transport, residential, commercial, others. Why is transport showing so little? Because I think this is electricity, sorry, this is not energy usage, this is electricity usage. So far the transport is using very little electricity, trains are using electricity. This is not energy, energy usage will be worse, but electricity, if you can see, this is what can be done. Industry is the biggest polluter, with top 10 industries contributing in the world. As I told you, industry, buildings, transport, agricultural land, others. The top 10 industry out of this, iron and steel is the biggest, chemical and plastics, cement, these are 3 biggest uses, look at the numbers. Then there are aluminum, refinings, machinery, pulp and paper, ceramics, food and tobacco, other metals, lime, construction, glass, wood. Can they move to electricity and become more energy efficient? That is important, and that is what we have to look at. Otherwise, they are highly emitting. Let us look at some other things. Hydrogen. Hydrogen fuel is clean and flexible, very clean. Hydrogen can be burnt used directly or mixed with oxygen into a fuel cell. So, it can either be fuel cell or burnt. Now, you remember that hydrogen fuel cells are not new. In 1960s, it was used with the rockets, and tomorrow hydrogen will certainly be very important for these 2 things. One is powering rockets, planes, maybe trains and automobile. Trains can be electricity. Automobiles, this makes what the long distance truck transport will use automobiles. Industrial use, as I told you, is a major usage that can be done hydrogen. But you know, hydrogen is not an energy source, it is an energy carrier. So, you use renewable energy to make hydrogen or some other energy. So, hydrogen needs to be made something. So, if it is made from renewable energy, of course, it is very good. But if it is made from fossil fuel, which is done today, it is an indirect use of fossil fuel. This is not making our hydrogen good. And today most of the hydrogen is generated using fossil fuels. Of course, hydrogen is far more energy density compared to battery. You can compress the hydrogen and you can do fast refueling. It requires infra and technology support like charging, more like petrol pumps. There are huge safety concerns. Compressed hydrogen is not good, but industry can make it safe. Cost is 800 to 900 rupees per kg. But what does that mean? We will come to that in a minute. But you know, there are different hydrogen. If you look at it, there is a black hydrogen made from coal, the most polluting. There is what is called brown hydrogen made from biomass and lignite, which is also highly polluting, or blue hydrogen from ammonia, which is better. Green hydrogen from electrolysis using renewable electricity. So, until you use green hydrogen, This cost 800 to 900 is for these things today, not for green hydrogen. Green hydrogen is more expensive. So, the energy used to generate hydrogen, lowest energy form is coal biomass, higher using ammonia, reforming passing through a catalysis to form hydrogen. But if I am using ammonia, one say should you make hydrogen from ammonia or use ammonia directly? It can be supplied in liquid form, just like hydrogen can be supplied in liquid form. So, the question that is starting to ask, if you are going to use ammonia, why not have long distance trucks for using ammonia directly instead of hydrogen or hydrogen? Look at this. If I use a fuel cells to convert electricity, my cost is 80 to 90 rupees per kilowatt hour. It is even much higher than petrol cost per kilowatt hour. Petrol I can today convert at 25 rupees per kilowatt hour. This is much higher. Diesel generator does that, diesel. There are other methods where one is promising 50 to 60 per kilowatt hour, but not sure it is clean. This is the number 80 to 90 rupees per kilowatt hour, lithium ion battery 7 rupees per kilowatt hour. And still the drums the government beats is hydrogen. Why? First of all, particularly during Trump days, United States moved away from renewable energy. Their declared policy was to use fossil fuels, and they started promoting hydrogen, because all this oil and the whole Middle East and oil industry, they feel that hydrogen is very much like they didn't want electric vehicle, they wanted hydrogen, and India more or less copies. The Middle East of course still pushing hydrogen, and while hydrogen is useful particularly for industry and we need that, but blindly beating that is a problem. Remember the cost. Can the cost come down to by 10 times? Yes, doable. That will require R&D. If it comes down to 8 to 9 rupees, this is only hydrogen to electricity, this is not storage. We have not taken electricity to hydrogen. We have to take around that. So, this is electrolysis, same stack, this is also very expensive right now. So, together it has to come to 10, 12 rupees for us to make sense. As I talked about high temperature industrial heating from 150 to 1000 degrees, there is no comparison. Ammonia can be a soft option, but otherwise hydrogen. But yet hydrogen is known to projected to become a $500 billion industry. Let us remember one more thing, energy that goes into hydrogen, what comes out is less. So, the question that some people are starting, why not use renewable energy directly? Well, the only answer is some place hydrogen is better, particularly in industrial usage, and maybe in heavy duty automobiles, because carrying battery will be a problem. So, there is no doubt that renewable energy to electrification is the best way to drive decarbonization in near term. Once you get to 70-75%, hydrogen will play a very important role. For industry, it will play an important role even today. Let me very quickly go through flow battery. Flow battery, there is liquid, anolyte and cathodolite, and there is a flow of this liquid through these battery elements, and these are vanadium, used to be touted like anything. Today vanadium is not considered that good, but there are a whole lot of zinc bromide, zinc ferride, hydrogen bromide, zinc iodide. These are batteries which works. They are still in R&D phase, still very expensive. Particularly, these are something highly promising. So, this is zinc polyiodide. This is what happens, zinc and iodine are interacting. Its energy density is 167 watt hour per liter, less than lithium ion, but theoretical energy density is 322. Cost is not that high. Materials for this is more easily available than lithium and cobalt, and therefore, looks somewhat promising. So, work can go on zinc this thing. But there is this airflow battery, which is only one way battery, in the sense that it acts as a battery on one side, you can discharge the battery. You have to put this, for example, aluminum air, zinc air, lithium air, there are a lot of options. You can put zinc into this, you can put electrolyte and it acts as a battery. It is a one time usage battery, one time in the sense after you take all the electricity out, zinc is gone, electrolyte is gone. You have to put fresh zinc and fresh electrolyte, that is charging fresh zinc. Now, what do you do with the spent zinc and spent electrolyte? Fortunately, there is a regeneration process by which you can take the get back the zinc and get back the electrolyte. This will is like a storage. There are two different plants. One is you keep on creating new zinc and new electrolyte, store it, whenever you need it, use it in the other battery. This, remember, if you can do it and do it cost effectively, you can keep it for 3 months. Zinc and electrolyte will be somewhat voluminous, but not that bad. This can be stored for 3 months. Of course, cost will go up like anything, because you may not use it all the time, but these are promising things which we should not roll out. We should start working on it. We will have separate plants. Whenever there is excess electricity, those months we will run those plants and generate zinc and electrolyte. Those wherever is a deficit, you start using this. So, this may complement lithium ion batteries and chilled water batteries, maybe 5 to 10%. That is what we really need to look at. And today's zinc airflow battery, of course, is not, while the theoretical capacity is 1000 watt hour per kg, which is very, very good. Lithium ion you do not get more than 300 today, though today we are getting about 400 watt hour per kg, 300 watt hour per kg actual, and they are slightly costly, but this is where R&D is required and India needs to pursue this R&D. Going forward, India would require, of course, expand solar and wind, play an important role. Third source is important. Small nuclear plants, it will take 15 years for us to get there. Small nuclear plants can be like a tabletop plant, not exactly tabletop, but small room plant. Can we have that? You know, ocean energy today, large ocean energy, there are plants which convert to electricity. Coastal India has ocean waves are much smaller. Nobody is doing enough work on that, but that could be another work that could be very important. The next very important is having a grid, very good grid, so that if power is generated in Rajasthan, it can be brought here. If wind is coming in Tamil Nadu, it can go anywhere. That work, and can we have a grid across countries? For example, if I can go to a grid all the way to Saudi Arabia, when ours is evening, when we consume a lot of electricity, theirs is daytime. That time they will generate a lot of surplus. Can I bring that? My storage will also not be required. Similarly, can I do that whenever early morning we do not have electricity, but Malaysia or Singapore or Vietnam will have, can I bring that? can I put a grid in the country and throughout the. Now, of course, you have to work on storage, as I told you, zinc air, zinc metal, aluminum air, chilled water storage, hydrogen, pumped hydro, all of them are important. Electric vehicles we have talked about, this is the high priority. Enhancing energy efficiency in air conditioning will be another top priority. Low temperature heating, we need to do all kind of efficient heat pumps, that is a good area for Dr. Kaushal to work, and for high temperature heating, hydrogen, and then decarbonization. If you are polluting, can you take the carbon out from the polluting gas, can be another work. Agriculture, solar pumps can play important role, electric powered tractors and machinery can play important role. Construction, can we replace all the machinery that we use by electrically driven machinery? Sure, something it can be done in the next 4-5 years. All kind of policy interventions will be required. Time of usage, electric charges, speed of economically viability, power management, make the wheeling policy way better. All this requires work, and this is exactly what we plan to do. And this is another assignment, and with that I complete chapter 8. Thank you very much.